Good morning, everyone. This is Nagesh Kumar Vinnakota, Software Engineering Manager at CapitalOne. So we have Gokul Prabagaren, a colleague of mine, who will be like a co-speaker for this session. First of all, thank you so much for having us today, and hearty welcome to Open Source 101 session. All right, like how many of you been to Disneyland? Wow, that's amazing. And how many of you been to Legoland? Excellent. I'm sure like you all might have like a very fun journey in those lands. How about like, I know like the spring break is coming up, and how about like having a tech ride? Anyone is interested in the tech rides? Excellent. So today we are going to take you to an adventurous trips in the space of Cassandra land and Mongo land in TCP/IP Spark. Okay, excellent. Before we go into this adventurous trip, so we are going to cover the lessons learned from having Spark applications coexist with NoSQL databases. Primarily, we are going to cover Spark with Cassandra and Mongo databases. Before we go into this journey, I would like to talk about CapitalOne. So CapitalOne is a founder-led company. We started in 1988, and the goal is like we have this unique culture that is driven to a strong sense of innovation and entrepreneurship. So we are like a leading bank, amazing bank, that is like offering a wide range of financial products and services to our individuals, small businesses, and the commercial clients. This is my favorite one. So we are the first US bank that fully transitioned from the on-premises data centers to the cloud. It was a bold move that modernized the bank's infrastructure and improved the scalability, flexibility, and the security. It also showcases that CapitalOne's commitment towards the innovation and leadership in the digital transformation for the banking industry. We have started this journey in 2016, and by end of 2020, we have fully migrated. Fully means like 100% we have migrated to the cloud. And I completely feel proud that we have set that example in the fintech-based companies. So we have also given back in the form of community, especially in the form of open source contributions. Some of our core contributions are the Cloud Custodian. This is a very popular tool for managing the infrastructure that allows users to define policies of resource management, security, and cost optimization. So this tool is primarily supports multiple cloud platforms today: Amazon Web Services, Microsoft Azure, and GCP. And we have another popular tool called Hygia. This is about like a DevOps dashboard tool, which helps you to manage the real-time insights of your health of the software pipelines. Along with that, we have other tools, especially the Data Compy and Data Profiler. The Data Compy is more of handling the big data applications, like when we are kind of want to learn about our data. So this tool is very popular to use it. Along with that, we have also given back in the form of community for the education. One of our popular programs are Coders. This gives the ability for the young aspirant future generation engineers like to pursue their career as a technologist. And we have also another program called Coda. This is primarily a pathway for the non-technical aspirants to pursue their career in the tech. So today agenda, we are going to give a quick refresher on these three architectures like Spark, Cassandra, and Mongo database. And we will talk about the rewards use case at CapitalOne. And we will take all of you to this amazing rides to Cassandra land and Mongo land in TCP/IP Park Spark. And finally, we will leave the floor for the question and answers. All right. I know like most of you have very familiar of these technologies, but for the sake of like audience, like we want to give a quick overview of these three technologies. So the first one is about the Spark. So it's very popular in-memory parallel processing framework. So primarily it consists of like a Spark context object program, which is primarily essential like a driver program which manages the Spark applications, and the cluster manager is the one which is responsible for managing resource in the Spark cluster. And we also have the executors, so which are responsible to, which runs on the worker node. Primarily they are responsible for executing the tasks. And we have the RDDs like resilient distributed data sets, so which takes the actual computation. And finally, we have these actions on the floor like which do the result set on the Spark. And the next one, with the Cassandra. So absolutely this is another popular distributed NoSQL database. So this is a columnar oriented database, and absolutely there is no single point of failure. As per the CAP theorem, this is like a high available database. And the core concepts here are like partitioning and the data model and the replication, and it uses primarily the gossip protocol to communicate between the nodes and snitch to find the nearest node for doing the read-write operations. So this is widely used. And the third one is the Mongo database, which is a schemaless database, and primarily again this is another popular NoSQL database for document based writings. And again here also it's primarily focusing on the replica set and the sharding, and where you have this responsible for data scattering across all the secondary nodes, and again like this is again another popular one. With this, I would like to talk about a high level architecture at CapitalOne. So as I said earlier, like CapitalOne offers a wide range of products. Today we have a Quicksilver product, which is like a cash based products, and we have if you are a frequent traveler, so we have VentureX cards. And if you are a consumer of like, if you are like, I'm a big fan of this card, especially SaverOne card, if you are like spending most of your time on like dining and entertainment. So all these are like various products that we offer today for the millions of customers. So let's say a friend of mine, Gokul, have SaverOne card, and he used his SaverOne card at Starbucks to buy a coffee at Starbucks. He swiped his card. The moment he swipes his card, a transaction is posted in our loyalty program. On a given day, we receive these kind of like millions of transactions from customers, and we have this loyalty program which has like a series of like Spark jobs. So like a lot of computation goes over there, which has the responsibility of calculating earn. So as I said earlier, like each product offers as a business point of view, like if you use SaverOne card, you will get 3% cash back for every transaction at dining and entertainment. If you use your travel card, you will get some miles. If you use your Quicksilver card, you will get 1.5% cash back. So all these transactions are like posted. Now our job is like to pull some data, apply the rules on this data, and compute the loyalty for that customer's transaction. All such transactions is posted in our Cassandra database, and as well as we are kind of posting all the data into the Mongo database. So these are our primary sources of data for having the aggregations, for having all the calculations for the customer. So now on the front end and all the consumers of it, like especially the front end UI that you see at CapitalOne, or like the credit statements that we send to the customers, are the primary consumers of this data. They are consuming the data from these two databases. So this is the overview of how we are using Spark and Cassandra and Mongo. As I said earlier, Spark is something we are using it for the computation, and the Mongo and Cassandra are primarily like handling the transactions, and finally like Mongo for like putting the data into the customer's account. With this, I am very excited for the Cassandra land. I'm sure you all might have got your tickets. So let's go to the Cassandra land. Over to you, Gokul.
Awesome, Nagesh. I think Nagesh was pretty thematic, so he was able to get all the things about level setting, what are the things we have in our platform, particularly with respect to our computation, data stack, and also what are the data stores we use. With respect to that, so I think we covered the ground to all the details. So I think it's time for us to take our first ride in Cassandra land. I hope you all will be probably able to collect some souvenirs, some tips or lessons while taking this journey along with us. The first ride we are going to cover today is token ring Ferris wheel. By the name, you would have guessed, the Cassandra land has decided to take a major transformation of their IT processing, and then surprisingly, they picked Cassandra as their backend data store, and the information about all the customers who are taking the token ring Ferris wheel ride, and their information is persisted in Cassandra. And schema goes like this. There is a customer category and their customer ID detail and their details about who they are and when they got enrolled, all those details. Then our friend, Mr. John Doe, who is a season pass holder in TCP/IP Spark, has decided to take token ring Ferris wheel ride today, and seems like after taking the ride, his whereabouts are not known. And Park security, they are scared and they are trying to find Mr. Doe's whereabouts. What has happened to Mr. Doe? So using the information they have about the who have taken the ride, and they know it is Mr. Doe, and they are trying to find his whereabouts using some sort of a query like this, where they have keyed in some information about Mr. Doe's customer ID and what kind of a category he is at this point. He's a season pass holder, and they are just trying to fetch his information. Hey, what has happened? And after finding this query, what they expect? They should get some details about Mr. Doe and what has happened. But the response they got was something like a spinning wheel. Can anyone guess what could be the reason? Like why we are not able to fetch the details as we expected from this? Any guesses?
Too broad a search.
Sorry, can you speak it?
Loads of data.
Lots of data.
Okay.
You're close.
You both are close.
Too many responses.
Okay, that's another interesting one.
Yeah.
Any other guesses?
Small. Yeah, you both are very close. So the main thing we need to consider for Spark-based application when we are using Cassandra, for that, say any Cassandra, the key sequence while you're firing the query matters. If you have noticed, I know it's too small, but if you have noticed, the query we have used, or Park security has used to find Mr. Doe's whereabouts, they have slightly misplaced the category and the customer ID. That is the primary key, or in Cassandra terms, the partition key, how the table is structured. So the inherent nature of Cassandra partitions the data in the backend. Pretty much how it persists in the data store goes by the partitions. So if you slightly alter those sequence, Cassandra doesn't know which is the sequence it has to go, because it goes by the definition of the table, the partition key it has. So in this case, it was, instead of using the category ID and the customer ID in the sequence, they have misplaced it. So Cassandra was trying to do customer ID as the primary search, and it has actually done a table scan. That's pretty much what you both were saying. Instead of hitting the right partition, we were doing a broad search, and that, instead of giving us the accelerating millisecond response, we actually didn't get any response. The Park security realized that, and they have altered the query. So they altered the query, and they were able to get Mr. Doe's whereabouts. Seems like Mr. Doe is like me, who collects souvenir whenever who goes to theme parks, and he was buying some souvenir in the Cassandra land while completing his ride. Let's move on. Continuing the theme, the next ride we are going to take is partitioner roller coaster.
All right, this is interesting and favorite ride. So let's say in this scenario, the same park, I know like most of the people, even though they offer a single ride, if I'm like, I pass the lines and I will just try to go for another ride, right? So they want to find, the park want to find the people who are kind of taking, too many rides. But since they are using the same Cassandra schema, so the ask here is like, they want to pull out the customers who are taking multiple rides. But the problem with this here is, if we notice here, the data is primarily partitioned by the customer ID, category ID, and customer ID. But the question here I have here is, I want to pull the data based on a specific date. I want to pull the customers who are taking multiple rides on a given date. Since we need to find, we have to scan through the complete data, it might take a lot of computation time at the Spark to pull the data, because I have to pull the data and apply some kind of filtering logic to pull that information. So what we have to do in this case? So to handle the first use case and the second use case, both are pretty much similar. The design went through at the beginning stage. So the goal here is like, the data has to be modeled upfront. So when we are designing, when we are choosing Cassandra as our primary database, we need to ensure that we have the right partition data. For example, let's say if I want to find a person like who has an SSN, like every individual has an SSN here. So if I want to find, if I knew that the person is from North Carolina, why should I scan the entire United States to pull that information? So the goal here is, if we knew that, we have to partition it by state so that Cassandra has that ability to jump to the right partition and pull the data. That will save a lot of computation time at the Spark, at the Cassandra side. So partition your data accordingly to the needs. And finally, use case driven model. This is very important, because as Cassandra, once we cannot change the schema of Cassandra, we need to ensure that what are the use cases for Cassandra. Only then we have to design our schemas. Otherwise, it can lead to the anti-patterns, especially when you are processing millions of transactions. It can take hours together to give the desired result. So always try to design your schema upfront and identify the right partitions, and as well as identify the right clustering keys to sort the data. Otherwise, it can lead to too much of response time for the result. So design your data modeling in the beginning of the development. This is very, very important step that we have to follow as part of when you're choosing NoSQL database as your primary database. With this, I will give it to Gokul again for the ride 3.
Cool. The next ride we are going to take is tilt a wheel. This ride, we are more going to focus on friendship, right? Going to any theme park without friends, what's fun in that? Or any companions that matter. So this is more going to focus about such a friendship. friendship takes commitment from both the parties. So if you want to have a lifelong friendship, it requires a lot of work, a lot of commitment from both the friends. So the first friend, Spark partitions. So in this case, Spark splits the data as its partition for in-memory computation across its worker nodes, and that's pretty much is what parallelizes the data, right? Nagesh was also previously alluding RDDs, and that is the primary data set in which Spark operates, and they push those things to executors, and that is in Spark terms is partitions. Same way, another friend of Spark, Cassandra, also partitions the data, which pushes all this information to that respective node. That data, how it partition, primarily through the key we define in the initial stages of our use case. And that key is how it keeps them actually in the disk. And that is what is also used to fetch the data quickly from the Spark. So for the application, if they want to really keep these two friends as a lifelong friends, they have to really ensure that they are doing the predicate pushdown. The predicate pushdown in this case, just connecting to the same example which Nagesh was also touching on, if you want to really fetch some information which is more pertaining to a state, why you scan for the country, right? Keeping that same, you can achieve that in two different ways. One, do this push down to the server and ask for the information from the Cassandra partition itself. Give me the information for that particular state. That's the first way. The second one, instead of doing the predicate pushdown, you can also fetch all the information and use sparse computation and filter those things, which is not an optimal way of doing this. Instead, push all those things to the server side, in this case, Cassandra side, so that you achieve the optimal results and keep these two friends as lifelong friends. I hope you all were able to get something out of our rides in Cassandra. I'm expecting the Mongoland also probably offers the same kind of things while we are taking some rides in Mongoland. The first ride we are going to take in Mongoland is schemaless carousel. You probably might have remembering our friend from Cassandra land, Mr. John Doe. Because of his loyalty to the TCP/IP Spark, the Spark authority decided to give Mr. Doe a free membership upgrade. So while they're trying to process Mr. Doe's upgrade, in this Mongoland, if you have noticed, the same data, because it all came from the Cassandra land, so they are trying to keep up the same. You can imagine any organization, any IT transformation, pretty much the schema remains same, most of the things remain same. They have migrated to a different data store. So they are using the same information and trying to process Mr. Doe's membership upgrade in Mongoland. While they fired that upgrade query, they didn't get the desired result. Instead, they got out of memory exception from Spark Java application, which is undesired result. Seems like the database has gone down after firing this query. The key lesson here is, in this case, whenever we are dealing with Spark Mongo application, you have to always maintain the Mongo connections at JVM or partition level. So I have abstracted things just for brevity, but if you take a look at this, there is an RDD we are operating on, and it operates on each partition. The recommended or must is you have to always operate your Mongo connections at the partition level so that you have things under control. How much ever partition you are opening, the connections are also will be one-on-one. Sometimes, instead of opening those things at partition level, people probably do that in a lower level where Spark decides those things on the executor level, and we don't have control of how many connections it really opens. So that has a potential to open a lot more connections, and in turn, it can lead to actually database outage. So it is always recommended you do the connection management with respect to the Mongo at the partition level for your Spark applications. Moving on, we are going to cover about another thing in the game feed, and Mr. John Doe's membership upgrade didn't go through yet, and he is pretty pissed off. And we are still trying to convince him, and we are again firing the query to get the membership upgrade for John Doe. So the schema remains the same, and we are trying to process. This time, we are trying to specifically do similar to what we have actually done in the Cassandra side. We are trying to identify John Doe case and what is his document and what is the information we have about John Doe, and we are trying to process the update. So if you have noticed the query, it's more like we are filtering and trying to identify John Doe using the category and the customer ID, and then we are trying to process the upgrade from a season pass holder, and he becomes a paid customer with a free upgrade from Spark Authority. So John Doe was very excited, and he was expecting this thing to go through so that he can reap a lot more benefits. And after he fired, again we got the undesired result.
Any cases what could have gone wrong this time? Why the query is taking too much of time to enroll John Doe into the Mongoland? Maybe we can primarily focus on the customer category ID, and
It's more on the.
It's a common mistake that any developer can do when they are querying Mongo through Spark applications. It's a common mistake. Like I have seen many developers doing this mistake. So, any guesses? All right, over to you,
Moving
Gokul.
on. So if you have noticed, we are trying to identify John Doe's information. Mostly when it comes to the Mongo, the type of query for this scenario is used is find and update. Whenever we are doing that, there is a find query which gets fired against the server, and that find has to be very precise. How we achieve that? If we are not doing the fine-tuned, there is a potential that you will do table scan before we really do the update. So how we solve that? Before the find executes, we need to establish index on the right keys on the Mongo side. Then only we will be able to process the update, and that find has to be against the index. So with this, we are able to establish the specific index so that it always hits when we are trying to find a particular customer and then process their update. And Spark Authority, they were able to process Doe's upgrade, and Doe is happy. Moving on, the next ride we are going to take in Mongoland is Kingdaka, and to bring us all home, Nagesh will continue.
All right. Thank you so much, Gokul. So how many of you have been to King Dhaka? Okay, that's an amazing ride. Next time when you go to Six Flags or like anywhere, let's try that ride. I'm sure like you'll scare to death. All right, so the King Dhaka, which we talk about, like, the first thing which we discussed about earlier was like, we are kind of processing millions of transactions. So when you are kind of dealing with Spark, Mongo, and Cassandra, primarily Mongo and Cassandra kind of storing these millions of transactions, and Spark is responsible for computing those transactions. It could be any kind of an operation today. The problem here is like, if we don't choose the right partitioner, it can lead the Spark to perform like, hours together to, process those data. So it's always important to find the right partitioner when you are performing operations. Like we have like today various partitioners like sample partitioner, sharded partitioner is one of the famous one, and also single partition partitioner. So PageNet by size partitioner as well. So figure out the use case and also try the right partitioner with a smaller use case, smaller data set, and take the response times for the every use case, then try to implement that on the millions of transactions. This is very important. So fine tuning is a iterative approach. So that we have to do, and as Gokul called out in the previous slides, so we have to index as and when. If you're choosing Mongo as one of your primary data source, you can add those indexes that will help you to do the right search on your Spark. Otherwise, it will ill you to like, we have to increase the memory size for the Spark as we are processing millions of transactions. So fine tune your Spark Mongo connector partitioner upfront. So with this, I'm sure like we have a lot of use cases that can talk, but the problem here is like time. So with this, like we would like to, I would like to hand it over to Gokul to quickly talk about him.
Hey, I'm an engineering manager at CapitalOne, and I have pretty much been involved in developing Spark and Java application from its initial versions, and I have given many talks mostly in the areas of big data and similar thing whatever we have covered today, and I have written about same things in CapitalOne media blogs in the same area, and I have shared my social handles. You can hit me up there.
All right, so myself, Nagesh Kumar Vinnakota. So I'm engineering manager at CapitalOne. So I've been leading teams that build full stack applications which are highly resilient, fault tolerant systems. And we are kind of processing millions of transactions on every day. And all of these are like a seamless experience. So I'm also like a tech speaker. And you can also find me on LinkedIn and Twitter. So with this, we are done with this tech talk. And CapitalOne, what's in your wallet?